So, hello YouTube. no, hello YouTube. Hello Facebook. Hello everybody. I'm hoping you can hear me. If you'd like to give me some feedback so that I know that you can hear me, I'd really appreciate that. So hopefully my computer won't blow up this time. I had a bit of a technical glitch there, trying to run two computers at the same time. Facebook seems a bit slow. Right, so excellent. We've got YouTube and Facebook Live working at the same time. This is amazing. This is my first time. I've got two different computers, two screens. Ah, right, okay, so
see if this works then, everybody.
That's confusing. Hang on a second.
So we're live streaming to Facebook
So I turn the volume off on this one.
and YouTube at the same time.
Very slow. Sorry, everybody. Come on, computer, don't die on me again.
So,
oh, right, hang on.
no. Hello, you.
Right. Let me just
YouTube.
do that.
Hello, Facebook.
Right.
Hello,
Is that working? Right.
everybody.
Okay, so let me close that down because that's a bit confusing. Right, now we've got that sorted out. So I've got, yeah, echo and lag. Excellent. Okay. Let me just see if the Facebook live stream is stable. It says it is. It says it's stable, but there seems to be considerable lag. So let's just see that. Okay, right. So how is everybody hearing me now? Can you all hear me in sync, or how's it going? Somebody says there's some echo and lag. Right. Okay, so I think that's set and working, I'm hoping. Not getting any let's have a look at this. Is that working live? Oh, hang on. Oh, here we go. Right, so let's turn that off. Right. So that's Facebook. That's YouTube. Let's see how we can get going. YouTube responds much quicker. Okay, that's interesting. Thanks for that, Demetrius. Okay, right. So today, itinerary today then. So I wanted to just briefly talk about the questions that people have asked, and also talk a little bit about the upcoming course that I'm putting together. So first things first, thank you very much for joining me on this live stream. It's a bit, I've never done this before apart from the trial I did a couple of weeks ago, so I'm still a little bit sort of nervous getting used to the technology. You might not realise, but I've actually got two computers running simultaneously, streaming to Facebook and YouTube at the same time. I've not been able to find a technical solution where I can broadcast to both at once using one computer. That'll be for next week, hopefully. But essentially, I wanted to try this new technology out because I want to be able to reach out to more people, spread the message about stamp-based safety assessments, and then help people with any issues that they have. So either help them with their learning about the methods, the methodologies, or if they have any actual issues and they need some support, then I'm available and can do that. So the intent of the upcoming cast accident analysis course is essentially the first in a series of trainings that I want to provide. I'm going to do it through the medium of the internet online so that people can do the training and learning in their own time, and they don't have to travel anywhere around the world and suffer expenses and inconvenience. So my intent is to use the media of the internet so that I can reach more people and help more people and solve more issues with safety and safety management. So I'm hoping you can bear with me as I learn about this stuff, because whilst I am a bit of a techie, a bit of a geek, this is completely new to me. And not only is the technology new, I have to get used to speaking on the camera, because normally I do webinars and speaking engagements, and it's not that intense because it's basically you and a computer simple thing. Whereas this is a bit more involved, a bit more technically challenging. So please bear with me. If you do have any issues, please type in the comments box and let me know, and I'll try and get to it as best as I can. The Facebook live stream on my phone seems to have frozen, so I don't know if anybody else has seen that. But if you do, then please try and say something. Okay, right, so first off, I'll talk about the course. So I'm putting together a CAST accident analysis training course, an online training course. CAST standing for causal analysis using systems theory, or causal analysis using STAMP, depending upon what literature you've read. And essentially the intent of that course is to help people who are already experts in the field that they're involved in, and then help accelerate that and transform them into people who can use the CAST-based assessment method in whatever domain that they're working in. Now, I'm predominantly from the aerospace domain, the defence domain. I do have some automotive, healthcare, pharmaceuticals, IT and nuclear related experience. But my predominant background is aerospace and defence, from fast jets, big aircraft, helicopters, jet engines, weapon systems, all of that stuff, the whole shooting match basically. Now, sort of my background and my story, I sort of first came across the stamp-based assessment methods back in probably 2009 was the first time I saw some of the papers, and then it was sort of 2010-11 when the good Professor Nancy Leveson, she released a free PDF draft copy of her book Engineering a Safer World. And being me, bit of a geek, I'm interested in learning, a lifelong student. I essentially started looking at that book and looking at some of the diagrams and pictures in there, and it started to dawn on me that this was a different way of thinking about safety, and actually it answered a lot of the questions I had about the more traditional methods like fault tree, event tree, FMICA and the like, and bow tie. And I found that it answered those questions, but also dealt with their limitations. And for me, that was sort of a groundbreaking moment in being a safety engineer. Having all of these challenges with safety techniques, never really being confident that we'd captured everything and dealt with everything robustly. And then along comes this method, and it appears to show some significant potential. And so it was at that point I decided that I wanted to sort of immerse myself, learn about it, meet the various people, get involved, get practicing with it, and see whether it really could do what I could see that the potential for. And so over the last sort of, what year is it now? It's 2017. So the last sort of four or 5 years, I've really put some significant effort, time and money into learning the methods, meeting the people, and trying to build a following. Because I can see that this has a significant potential to literally revolutionise the way that we do safety engineering and risk assessments and safety management. So, and this is not just confined to one industry. This is literally every industry, even upcoming new technologies such as nanotechnology or the autonomous vehicles. So I'm a passionate safety engineer, I'm a passionate learner. I like to think I'm quite a good communicator. I'm probably not. You'd be the judge of that. But I want to help people take advantage of this massive opportunity. I can see that it's streets and streets ahead of the other traditional methods. It's easier to apply, it's quicker to apply, and it gets more results, better results, faster. So my sort of mission is to help you and other interested people in taking advantage of the method, saving lives, reducing costs, and managing safety much better than we can possibly do today with the traditional methods. So that's a little bit about me, about my passion. I hope I'm not too passionate, but this is what I'm about. I want to help. I want to, sort things out. I've seen it done so many different ways. I've seen lots of interesting things that might turn your hair white, and I can see this has a real potential. And I just for me it's early days. The diffusion of innovation curve the use of this method and its uptake and the time it's going to take to become mainstream. We can't wait. We need to grasp this opportunity now, take advantage of it so that we can save more lives and, you know, save, you know, the cost of accidents. I mean, accidents, particularly nowadays, are so, you know, as expensive and, you know, devastating, and we need these methods to help us with dealing with those things. So, right. So, yeah. So the intent of the course is essentially to give you an introduction to the cast accident analysis method so that you can see, hopefully see, the way it could benefit you in what it is that you do. Now, as I said, I'm coming from an aerospace and defence background, and so the language that I use, the terminology I use, if you come from a different industry, may be slightly different, but so long as we talk about those differences and make sure that we're on the same page, we've got the same mental model, you should be able to learn this without too much trouble, and then I can help you in its application and your, you know, developing your skills in its application. Now, the course itself, it's going to be at least 6 modules. It's going to be delivered online, so that you can watch it anytime, anywhere that you've got an internet connection. You're not sort of restricted and you don't have to spend money on travelling. This first course is not going to be very expensive. It's not going to be thousands and thousands of pounds, so it should be accessible to you. And then, of course, the support I'm going to provide. We will have a series of calls during the time that we're doing the course. We will have some conference calls. They will also be recorded, so if you have any questions or challenges with the course or its application, then you can ask those questions. They will be recorded and they will be made available to you to replay it anytime you like in the membership website. Now, I am still developing the course. I've got the bare bones and the structure. I've got the case study. I don't know if you can see that. This is the case study that I'm using. It is an aerospace case study, and it relates to a helicopter accident offshore. So an oil rig serving aircraft over the Atlantic off Canada, Newfoundland, had a main gearbox failure and unfortunately crashed into the sea, and all but one, everybody died except for one survivor who was very fortunate. And it's a case study that was suggested to me by one of my contacts, because they're particularly interested in not only the technical aspects, you know, oil and gearbox faults, but also the regulatory and accident investigation and in-service support aspects, so safety management systems. So this training course, whilst it's an introduction to the CAST-based accident analysis method, no matter what industry you are in, you will get benefit out of it. But particularly if you work in aerospace, particularly the regulators, investigators, operators, maintainers, emergency response, if you're involved in emergency response management and planning, it will be of interest to you. And then also safety management systems, so people involved in in-service support. So if you work for an airline or a helicopter operating company, or even a military organisation, this will be of interest to you. Okay, so as part of my learning about marketing and developing online products and all of this jazz, I put out what's called pre-registration questionnaire. So I asked people who were interested in the course, in the topic, if they'd raise their hand and let me know, and then at least I have some idea as to whether I'm actually developing this course for some people who want it, or whether I'm wasting my time. Because it does involve a lot of work to put these things together, more so than I'd actually appreciated. So I've been really trying to get this done so that I can deliver it, and I want to make sure that people are interested and actually want it. Now, I'm not going to, as I said, I'm not going to be able to do it for free like I have done other things, because this has involved a lot of work, a lot of expense to acquire these capabilities and skills, and I need to be able to cover those costs. So, as part of the pre-registration phase, I asked some questions via SurveyMonkey, and a lot of people kindly responded. And I've got some questions and answers on here, so I'm going to go through those and answer those as best I can. Now, obviously, if you have any questions or comments, I'd really appreciate, I'd love to see them. So please type them in the box below, and I will do my best to get to those and answer those. But it's great to see you. I mean, this is awesome. I'm really sort of excited about this. Right, okay. So let's have a look. So I asked two related questions. The first was, what is your #1 question about cast accident analysis? And then the second question was, in an ideal world, what do you want to achieve from this training? And then finally, do you have any questions or comments for me, so people had an opportunity to ask anything? So I'm going to go quickly through, in an ideal world, what do you want to achieve from this training, and then I'll move to the other questions. So Gareth, thanks Gareth, I really appreciate you filling the questions in for me. He essentially wanted to, in an ideal world, have the skill of being able to build what he's termed an accident model, and I'm interpreting that he means a hierarchical control structure model. So he wants to achieve the ability to be able to do that. I can confirm as part of the course there will be exercises involved and potentially homeworks, depending how sensitive you are to that, where I will set a task and I will ask you to build or model the hierarchical control structure so that you can start to understand the principles of modeling and then get some practice at it. Frank said that in an ideal world he would like to do some practicing and he'd like some useful tips. So yeah, you'll definitely get the opportunity to practice. That's if you do the homework, everybody. And you'll get some useful tips. Now, as part of the course, we will have periodic conference calls where yourself and the other training team members can actually come together, talk about the ideas and share ideas and tips. Okay, Bruce. Thanks, Bruce. Great to see you. Bruce has said in an ideal world, he wants to adopt practices to understand system issues and identify and implement improvements. So now this is interesting because this is a bit of a crossover question between applying the cast accident analysis method and the STPA hazard analysis, systems theoretic process analysis. So in this training you'll learn about how to do the accident analysis, and so if there are any cases in your organisation such as Bruce's where you want to understand existing systems, organisations and processes, you'll definitely learn how to do that. And obviously as part of that you'll identify recommendations for improvements, and so if the organisation then decides that they're a good set of recommendations, then you'll be able to take those on. Now obviously as part of this training we're focusing on the case study, but if you do want to have a talk about your own specific industry, your own business, then we can do that. Okay, Steve. Hi Steve, thanks for asking questions. Steve would like to build confidence to apply the method and then be able to brief senior leadership on the results. So in this case we'll be focusing obviously on the helicopter accident, and Steve works in the aerospace, or more likely space. And so as part of this, I hope to build, or I expect that you will build some confidence in understanding the process and then how to apply it. And then where we have particular particular homeworks or you know, small case studies, examples, you'll build more confidence in applying the approach. And then of course, because we're looking at this specific case study, there are and will be recommendations that are directly applicable to, you know, if you work in aerospace or an airline, as I said earlier on, then you will find parallels and you may actually want to use some of these recommendations in your actual organisation today. And of course, then you'll be able to brief the leadership on results and say, hey boss, we've used this awesome effective method that's come out of MIT in America. I've done some training with Simon, it was ace, we need to send everybody on it. But what we've found is some really interesting things. This method is very quick, very effective, and it's allowed us to find very specific recommendations which we can actually implement or manage, do something about. And if you want to talk about how we can brief leadership on those kinds of results, perhaps that's something I could follow up in the future. We'll have to think about that. Okay, next. So Roy. Hi Roy. thanks for responding. So you'd like to get a clear understanding of the method. That's one of the objectives. You should get that understanding, and if you don't, we'll work together until it's really cemented and you'll really understand. As I said, for me, this is not about, you know, doing all this work and generating cash. Obviously, I'd like to pay my bills. For me, it's about the passion and about getting this method into the mainstream as fast as possible, because the longer it spends its time out in the wilderness, you know, people are dying, businesses are losing money, and it's bad. It's bad for the economy, it's bad for the environment, it is bad for everybody. So the sooner this gets to become mainstream, and the sooner I can sort of help people get there, in my view, that's the better, that's the best thing to do. Next question. So Amaya, I don't know if I've pronounced that correctly, Amaya, but she has said, the clues that will lead to prevent aircraft accidents in the future. So yes, exactly. This approach is specifically designed to do that. So yes. David has said he'd like to learn about the practical application. Yep, that's part of the course. That's one of the objectives. Patrick. So Patrick has said he would like to get sufficient knowledge to be able to start to implement CAST in his daily work. So I expect that you will get that knowledge, and that's my objective. I want you to leave this course with the confidence to go into your own businesses, you know, or whatever you're doing, and be able to start applying this method and be confident in doing so. And if you want some support after the course to do that, then we can do that, we can talk about that. Okay, so Joanna says, anything I learned from Simon is wonderful. Well, thanks, Joanna. I really appreciate that. That's very kind. Phil has said that he'd like to get a better understanding of the CAST process and the pitfalls to avoid. So yes, definitely. You will get a clear understanding of the CAST process. You'll get a clear understanding of the standard process that is described in Professor Levison's book, as well as the various papers that have been published. But I will also share with you some of my not secrets, but some of my tactics for being even more specific and more detailed in the analysis. So I'll teach you both of those. I'll show you both of those. And the reason I'm doing that is I want to make sure that once you've done this training, you have a clear understanding of a quick and dirty CAST accident analysis that you can do very rapidly, and then a more considered, more detailed version. Essentially, they follow the same process, the same rules, but in the version I've sort of developed further, you are, you know, the way it's laid out allows you to think more creatively and identify very specific causes of accidents. So that's a good opportunity. Okay, so Edgar. Hi Edgar, thanks for providing some questions, feedback. You'd like to get a good understanding of how safety specialists work across disciplinary divides. So this is an interesting one because, as I mentioned earlier on, I've worked across many industries, mainly aerospace and defence, but I've also worked across the different parts of the life cycle, so concept, design, development, testing, manufacture, in-service support, incident investigation. I haven't been involved in accident investigation, so I'd like to get involved in that in the future. And then also decommissioning, disposal, and then, you know, well, in the military weapons, not only you don't just have disposal, you also have to target. So, you know, design to target. Anyway, so I hope I can share some of that experience. But of course, as part of the calls that we do, that'll have various people on there, it is likely that you'll get people from different disciplines who can then share that experience. And so if you do take part in the course and you are on those calls, then obviously you can ask questions of each other, share experience, and network as well. Okay, so Gia, I don't know if I've pronounced that correctly, I'm really sorry if I haven't, but he said that he'd like to learn some good implementable measures that will prevent the reoccurrence of the incident. So yes, that's exactly what the CAST accident analysis method is all about. So yes, and when I say CAST accident analysis, I'm not sort of saying that you can apply this only to accidents. You can actually apply this to incidents and near misses. In fact, if you have an incident or near miss, that's actually telling you that there's something wrong with your system and you need to go and take a look before something more serious happens. You know, so if you use this method in incident and near-miss investigation, you can get so much more value, save so much more money. I mean, in the maintenance environment, for example, in aerospace, you know, a workshop or a flight line, using this method to analyze those circumstances can not only make things much safer, but it can also save you lots of money, lots of time, and lots of disturbance, which is basically, you know, when you have an incident or a near miss in an airline where the aircraft then has to wait overnight, the associated costs with that are astronomical. And so if you could get advantage using that method in that area, then by all means crack on and use it. Okay, so the next question is from Sujit. Hi Sujit, I don't know if I pronounced that correctly, again I'm really sorry. So you'd like to make a comparison with RTCA D0178C with respect to accidents. So if you don't know, D0178C is a software safety standard, and essentially what that does is it defines how you would develop software for, in this case, airborne systems like aircraft. Now, it's a bit of a difficult question, that, because you can't sort of compare a standard with standard requirements with a cast accident analysis, but the results of the cast accident analysis will tally with some of the things that are required by the standard. And so you can confirm that the analysis has got what's in the standard, but also identify more things that are not listed in the standard. I hope that sort of makes sense and answers your question. Okay, so next question. So John says, you'd like to get a better understanding of the types of causes that can be identified. So whether they are, for example, direct, contributing, or systemic. Okay, so yes, definitely. You will get that understanding. In fact, from my personal experience, my personal perspective, when I got experience with CAST and particularly STPA and focusing on the control structure and the control loop, when you start to think in terms of structure and control loops, you almost gain a sixth sense to be able to identify potential causes. And they can be direct causes, directly related to the physical process of controlling the hazard, but also associated with the organisation above it and also the interacting organisations. And if you want to go really detailed, you could start to look at the supply chain dynamics and potentially even security and safety of the supply chain itself. So yes, you can definitely get a better understanding. Cathal. Hi Cathal. You'd like to get an understanding of how to apply CAST to a process industry example. Well, this training course is going to focus on an aerospace case study. It is related to oil and gas, but it is to do with the aircraft operation and its design, maintenance, certification, and emergency response. So there will be some parallels, but with regards to a specific process industry example, I'm not going to be able to cover that in this training. I may be able to cover that in the future, but I can't guarantee that. That'll be something to put on the wish list. Next question, Peter. Hi Peter. So you'd like to learn about practical application to real-world operations. Okay, well, we'll definitely talk about that. The case study is a real-world operation, and if there are more specific things you want to know or questions you want to ask, we can do that on the conference call. And if you want to talk about specific real-term business issues, then I am available to consult and we can set something up. Okay, so somebody called Flynn has asked about safety performance. So CAST accident analysis will identify where there are issues with the safety performance of your business or organization. But it could also be used, so if you identify an issue with safety performance, you could actually use the CAST accident analysis to identify the issues that are causing that safety performance issue. So yes. And George, I'm hoping I pronounced that correctly, thanks George. You'd like to enhance comprehension of the methods so that you can start promoting it as a tool in your current job. Absolutely, that is one of the #1 priorities, #1 objectives. I want you to be confident and comfortable when you come out of the training so that you can basically go into your job, hit the ground running and say, hey everybody, I've got this method, it's very quick, very effective, and we need to be doing this because the sooner we do it, not only do we reduce costs and potentially stop accidents, we actually potentially improve the effectiveness of our business or operation. So it's, you know, win-win basically. Okay, so that's that question. Okay. So I'm just going to quickly run through the other questions that people ask me, and then I'll come back to the first question. So Frank said, what about the costs? And if it's London-based, I might have to stay with my daughter, but still have to pay for transport costs. That's okay. Thanks, Frank. Don't worry about that. It is, as I mentioned, it is an online-based course, so you can watch it wherever you have an internet connection at any time of the day, 24/7. The only thing that will require a specific time slot is when we do the periodic meetings, online calls, where we get together, talk about the training, talk about any issues you've had, and then talk about share knowledge and experience and tips, things like that. And that'll be recorded, so even if you miss those calls, you can watch those on your, replay those on your computer, you know, when you're available. But obviously if you miss the live calls, you won't be able to ask any questions. But if you do send them to me before that, then I'll address them on the call. And if it's something really serious that you want to address, then get in touch with me and we'll see what we can sort out. So yeah, just to recap, it is a paid-for course, but it's not going to cost thousands. This course is not going to cost thousands. Okay. So, yes. All right, okay, so Edgar has said, please consider disseminating my ideas on drones, vehicles, nuclear reactors, Internet of Moving Things. I've got lots of opinions about those. I won't go into them now because we've already been on for 40 minutes, but perhaps that's a topic for another live stream. Gear has asked, would I be willing to host a CAST course for investigation leaders in this location? Yes. If you require me to travel to wherever you are on the globe, I'm prepared to do that. I am available. And if you want to customize what type of course you want to do, whether it's introductory or detailed, then we can talk about that. So I'll be in touch about that. And Peter says he's got hundreds of questions, but he'll wait for further calls and training. That's fine, Peter. The more questions, the better. Because ultimately, that's what it's about for me. I've been through the struggle of trying to get my head around this method, get my head around the literature. You know, there is a lot of literature out there nowadays, and trying to get an overview of it all and understand the principles and how to apply it. I've been through that journey. I'm still going through that journey. I'm learning all the time, and especially the more that I help people, the more that I teach people, the more that I learn and are able to pass on. So yes, let's deal with those questions and whatever it is that you want to deal with. So that's those questions, right? What else? So Joanna's Joanna's made a bit of a point about she's really looking forward to this event, particularly given some of Air Canada's recent landings. So there's no criticism of Air Canada at all. I did do a recent video that's posted on YouTube. If you've not already seen it, go and watch it. Comment below. Like, share and subscribe, as the YouTubers say. So if you do like it, please share it around. I really appreciate it. It really helps me. But yeah, that incident was could have been quite serious if things had been very slightly different. So this is what I said earlier on. If you do have an incident, it's a warning. It's basically telling you your business, your operation, your control structure has some inadequacies, and that's why you've had the near miss. It's just fortunate that on this occasion, an accident didn't result. So take the opportunity now while it's cheap and go and investigate it. Using this method, identify the issues, identify recommendations, so that you can then make informed decisions about managing risk and spending money if you need to. Right, so back to question five. So this question was, what is your number one question about cast accident analysis? And obviously this question I will answer it as I go through the course. I'll answer these questions. So the first question from Gareth is, how can I use it? So yeah, you'll see how to use it. I'll explain it, and if you do have any questions, we can deal with those on the periodic calls. Frank has said, is it better, faster than any current investigation method? And what about smaller incidents, return on investment, especially time and knowledge? So I'll answer that in two parts. So, excuse me. So the cast accident analysis method is an analysis method. It's not an investigation method. It's not an investigation approach. But you can use it as part of an investigation approach. Because when you start to build the control structure model based on the information that you have to hand, you will start to see where there are either gaps in the model or interesting interactions that match the evidence that you have on the scene, or from witness statements, and then you can start to use that as a almost a compass to help direct the investigation to look for either more evidence or confirm some of the things that you potentially identify. Because accidents they're never simple. They are always complicated or complex, and more so they are complex dynamic processes, not just simple linear events and states that transition to an outcome. So this method is specifically designed for that, and it can be used in a full-on investigation, or it can be used in a small, quick and easy investigation, depending on what you decide to do. So the second question is, what about smaller incidents, return on investment, especially time and knowledge? Well, on smaller investigations, smaller incidents, you wouldn't necessarily want to go into the nth degree because it's a small incident. But it may be that this small incident is a warning, potential warning, of something much more bigger, more sinister. And it may be that, as a silly example, well, not a silly example, a serious example, but apparently minor. In this particular accident, as part of this case study, the aircraft crashed into the water. The emergency flotation system, which is designed to keep the aircraft on the surface of the water and stop it from rolling under the surface so that people have time to escape. The emergency flotation system, because the helicopter hit the surface of the sea so hard, it was damaged and destroyed to such an extent it didn't work. Now, in this particular accident, it didn't matter. It didn't make, because it didn't work, didn't make any difference to the ultimate outcome. But the questions then arise about the management of the flight operation. So this particular emergency flotation system was certified and designed for a sea state 4 condition. If you don't know the details of that, please look it up on Google, but it's essentially to do with wave height, wind speed and things like that. Now, it was certified to a sea state 4, but the helicopter's predominant amount of time that it flew, that it operated, was at sea state 6. I can't even speak, sorry. At sea state 6. So there's a management aspect there that, well, if you've got a certified system to sea state 4, why would you be operating it in a sea state 6? Especially if there's an emergency and you need to use the system. So there are questions there about operational management and safety requirements and certification. Okay, so Chris says, I'd like to learn how to conduct a cast analysis. You will learn that. Bruce says, one top question is how to frame the study, particularly for a series of projects rather than a single problem. So this is interesting because, I think this goes beyond this is definitely beyond what I'm going to cover in the course. but you will get guidance and support on the aspects you need to consider when you frame the study. So whether you're investigating an actual accident or whether you're investigating a near miss, that will frame the study very differently. Okay, and how do we know when we have enough? Oh, sorry, hang on, that's the wrong question. So how to frame the study, particularly for a series of projects rather than a single problem? Okay, well, the framework, the method, is applicable to any project, any system, but it's how you specifically apply it in your particular project. Now, if you're running projects which are, have the same framework, the same structure, then the higher level part of your analysis, the hierarchical control structure, will be the same or similar. And it's only at the very detailed lower levels that it'll be slightly different. And you'll be able to compare projects as well, the risk associated with two projects. Steve says how the cast analysis and evidence search processes can serve each other, and how do we know when we have enough relevant evidence to complete an effective cast project? So how the cast analysis and evidence search processes can serve each other. Okay, so I mentioned that earlier on. So if you've already got an existing investigation approach where you essentially quarantine the scene, collect evidence, analyse the evidence, form findings and conclusions and make recommendations, the cast analysis process can be used or included as part of the evidence gathering activity. You can start to create the high level control structure at that early stage, and that will help you potentially to find or look for other evidence or make decisions on whether it's worth looking for certain evidence. There may be circumstances where it's very time consuming and expensive to get certain evidence, and it may be that the cast analysis allows you to make decisions on maybe not looking and spending money on that particular part of the evidence. I mean, I'm not an accident investigation specialist, so I can't really comment about that, but we can certainly talk about that on the calls with the other people on the course who do have that experience. How do we know when we have enough relevant evidence to complete an effective cast project? Well, essentially, when you do the cast accident analysis, you start from the physical process, and so long as you complete analysis of the physical process, you can then make decisions about how far up the control structure you want to do the analysis, and you can tailor your approach accordingly to time and resources. From a physical process analysis perspective, you know that you've got a complete analysis when you've analysed the control loop and identified safety requirements, unsafe control actions, mental or process model issues, or physical failures. And part of the analysis process tells you what steps you need to go through. So as long as you've completed those steps, then you should have a good analysis, a good quality analysis. Juan talks about he'd like to understand how the analysis deals with systemic issues. So as we go through the course, we will talk about that in a lot of detail, because it does, there's two dimensions here. There's the control structure model that you create that will visually make it obvious that there are systemic issues with the system. But there are also, when you analyze the individual controllers, you may identify systemic issues across that entire structure. So somebody has a mental model that is incorrect in this accident sequence. May be that it is because the flight crew manual, for example, is not consistent with the training. And so you can see that that's a systemic issue, not just an individual issue. Okay, so Roy said he'd like to learn how to apply it. Yep, we can do that. Amaya says, how do we know that we don't leave anything behind? So I touched on that a moment ago. When you create the control structure, obviously it's a model of reality, and depending how detailed you want to go, will depict how many results, recommendations, and answers you get. And you can choose that. You can decide how detailed you want to go. But ultimately, once you've analysed each of those controllers and the interactions, so long as you've done that, then you have a complete analysis. That's it, really. So you can inspect it for completeness. And it should be, Once you practice with it a little bit and other people are experts at it, you will be able to replicate the analysis and get the same results. It is a systematic analysis and it will identify systemic issues. Got an itchy nose today. Okay. So David says he'd like to learn the method and use it in practice. Well, we can teach you the method, we can take you through the case study, and you can get some practice. If you use it for real in your business, your work, then I can support you in that, but that's not explicitly included as part of the training course. Okay, so Patrick, how do you translate the theory into operations for different levels of complexity? CAST seems great for complex problems with lots of time for analysis. How is it done for simpler, shorter investigations? That's a good question. So that's about how much time and effort is involved. So a CAST accident analysis can be done very quickly. The thing that takes the time, well, two things. The first is collecting the information to build a control structure and then analyze the control structure. But that is part of your normal investigation work anyway. It's not extra work. The only extra work that it might generate is if, as part of the CAST, you start to identify issues that you need to drill deeper into. But that's a positive thing because you're not missing those things. CAST is helping you drive those issues out. Now, obviously, the more complex the system is, the more complex the analysis is, and the more time it takes. But because it is a very straightforward, systematic process, you can, once you get pretty good at this, you can rattle through it very quickly. But as I say, the first part is building the control structure. You may need to iterate that as part of the investigation, part of the analysis, and then rerun some of the analysis. But once you've got into the swing of things, you can do it very quickly, very rapidly. I mean, the control structure I developed for this case study, once I'd got through all the information, because it is a pretty big accident report, once I'd got through all the information, the control structure was pretty straightforward to build. And I probably built it in maybe an hour, 2 hours. I have subsequently broken it into 3 or 4 distinct control structures because they address different things. But ultimately, once you've got the information there, it is quite a straightforward thing to do. And the more practice you get, the more experience you get, the quicker you can do it. And like Bruce was asking earlier on about other projects, once you've built the control structure for certain parts of your organization or the system you're talking about, it doesn't change that much. But obviously, over time, systems evolve and change, and you have to make sure that your control structure models, if you use it for safety management, you need to make sure that they stay current and that it's a reflection of reality, an appropriate abstraction of reality, and that the model doesn't deviate or become different or out of step with the real system. So, yes. Translate the level, okay. So Joanna has said, can it be applied to occupational health and safety? That's a brilliant question. The answer is absolutely yes. Yes, it can. It is for occupational health and safety. It is even more straightforward than for technical systems like aircraft and all that kind of stuff. Because the system that you're looking at, the system of interest, is more confined, more constrained. And in fact, I don't know if it's published on the PSAS MIT website, I'll have to have a look. But Boeing was at the MIT Stamp Workshop at the early part of this year, and they actually presented, I think, 2 or 3 presentations on use of CAST and STPA as part of occupational health and safety investigations. One of those was to do with a lockout, tagout process for managing the energy sources on an aircraft. So obviously, if you've got, in an aircraft manufacturing facility, you've got loads of people crawling all over this new aeroplane, fitting wires and hydraulics and testing things. And obviously, you don't want somebody to be working on the electrics while someone else is trying to test the electrics. And so one of the methods they use is lockout, tagout, and they use the STPA approach to identify what the control structure was, what the weaknesses were, and how to re-engineer it to make it better. So yes, it is very effective for occupational health and safety. But again, one of the challenges is it's not a risk-based analysis. It doesn't talk about likelihood. It talks about severity of outcome, but the stamp-based methods don't talk about likelihood and then the ability to calculate a risk or pluck a number out the air. It doesn't work that way. So if people are only interested in getting a risk classification or a number times a number, then they're going to struggle to get their head around that is nonsense. That's nonsense, and they should be doing this method and using this method. But as part of this course, I can answer those questions and we can talk about it, and then I can help you communicate with others, communicate the value of this in occupational health and safety. And in fact, so my background is focused on helping people with complex engineered systems. There is an opportunity there to focus specifically on occupational health and safety, but no disrespect at all. Blowing up power stations and airliners and oil rigs and all that kind of stuff, the outcome is so much bigger than hurting a relatively smaller number. I'm not saying one's better than the other or anything like that. I'm just talking about the priority that I've chosen to pursue. But we can talk about that. Okay, so that was okay. Right, okay, so Edgar. Hi Edgar again. Edgar has said that, oh hang on, excuse me, what's going on here? So I think that one is working. It says it's working, and there's apparently 2 people watching. Hello. Facebook. Is Facebook working? I can't tell. Come on, Facebook, are you working? Yeah, it seems to be working. And I've got... No, it's broken. Sorry, just bear with me a second, everybody, while I just fiddle about with this Facebook thing and see what's happening. So it doesn't... Right, come on, computer, you want to work. Sorry, YouTube. This is a bit frustrating. Why isn't it starting? Right, I'm going to have to restart my broadcast service on Facebook. I'm sorry, everybody, on YouTube. This is a learning experience for me. I'm trying to do too many things at once using 2 different computers. Right, so let's just press go. Let's see what happens. So it says it's connecting. Come on, Facebook, work. Says it's connecting. Says it's connecting. Come on. See, it was working fine. Oh right, okay. You see, that's a bit annoying. Stream. Okay. Right. Sorry everybody on YouTube. This is a bit embarrassing, a bit annoying. Okay, so I've got 2 people watching. Hello again, 2 people. Facebook doesn't seem to be working at all. It says it's connecting, but it doesn't seem to be. So, yeah, it doesn't seem to be working at all. I think what I'm going to do is perhaps abandon Facebook and continue on with YouTube, because it's not fair on you guys on YouTube if the Facebook channel's broken. Okay, so I'm just going to carry on. Right, so you can all hear me. We've all gone to sleep. I can see 2 viewers there. Right, so let's have a look. So this was Edgar. So Edgar said he'd like to see case studies where CAST experts conclude that something is not makeable for the sake of humanity. Now that is a really, really good philosophical, conceptual, mature question to ask. Now, because the insight of, well, more STPA than CAST. Well, in fact, yeah, CAST. Actually, yeah, we'll talk about CAST. So the Tenerife disaster that I did a video on, you can have a look on YouTube, and the recent Air Canada incidents, and also the CPDLC, Controller Pilot Data Link Communications issue that was reported a few weeks ago, where an aircraft received a flight level change command the day after that they were supposed to have done it. Now, I don't know the specifics behind that. I don't know if the aircraft actually changed levels when it received this late instruction, but that could have been really serious. Now, when you do the control structure model analysis, when you create the model, you may actually identify certain aspects with the concept or design solution architecture that you've recommended that actually does show that, you know, the system you've got is not robust enough. And this is one of the questions and concerns I have about remote tower, air traffic control remote tower technology, is that if the technology fails, the communications links fails, and you've got a remote tower on an airport and the air traffic controller is on a different planet or wherever they are, if that technology fails, there is nobody physically at the airport that can step in and maintain the control structure and maintain adequate control over the system of interest, so the aircraft landing. And an example of that is from you know, the Air Canada incident I did a video on last week or the week before. They talked about the use of a red light gun from the air traffic control tower to the airliner. Now, in this occasion, that mitigation was not effective, so there are questions about whether that really is an appropriate mitigation. I don't think it is. But if you're operating a remote tower, there is nobody at the tower physically to get the light gun out and point it at the aeroplane, or like on military airfields, they use people in a caravan with a flare gun. And so if you're coming in to land and it's not safe, they'll fire a flare that you can see, and then you go around. Now, if you are in a remote tower where you are reliant on the communication links, if those links are lost for whatever reason, you are now out of control of the airport and the air traffic. So there needs to be some other part of the control structure that can deal with that scenario. And it may be that there's a load of red flares get shot into the sky, so everybody circling the airfield can see that it's now closed because they've lost the air traffic control tower. But then the question then is, well, what if this airfield is a diversionary airfield and the person coming in to land has an issue and cannot go around for whatever reason, and you've just cut the head off the air traffic control structure? You know, so I have serious questions and reservations about that. And the impression I get is that there are a lot of people that like science fiction and like the idea that they can build these things with the technology that's available, but they're just not building them with the appropriate systematic robustness, control structure robustness, that can deal with all scenarios. You know, it's all right if you're 99% reliable all the time. I'm a safety engineer and we deal with that, but my main objective is to think about the bad stuff. If we have a bad scenario, can we still live? Can we still operate? And when you create the control structure, you can actually see in black and white, if it's a black and white drawing, whether you can or not. You know, so and this is where the CAST methods, the stamp-based methods can be used for developing a concept or designing or assessing a concept for its suitability. In fact, maybe having spoken about it at length, maybe I should do an assessment of the remote towers and talk about the different control structures. But then I'd be doing lots of free consulting for the air traffic control industry, and you know, but that's a separate discussion. So yes, you can use the stamp-based methods to make an explicit point that something can be done, but not necessarily done safely. And that's the same for autonomous vehicles. You know, what happens when the automation goes kaput or whatever? How can the driver take control in time before they have a fatal accident. Well, there is no time, so that control structure as proposed is not sufficient. And that's another topic I ought to do a video on. Okay, so why do I not... Oh, right, okay, so John has asked the question, why do I not see many upfront applications of CAST? I mostly see retrospective accident analysis based on extant accident reports. Well, there's two reasons for that. The first is I've not had the opportunity to be able to do any proper accident investigation work. I have done incident investigations, but obviously the nature of these things are very sensitive and are not something that would normally find their way into the public domain. Now, the information that is in the public domain is like this accident report, and I can use that as a starting point, but I can't demonstrate an actual investigation because I just don't have the information or ability to do that. I mean, if you do have one and you want me to come across and give you a hand with that, then get in touch, send me an email, and we can set something up. The other thing as well, reviewing existing accident reports using the stamp-based methods, it enables you to not only get extra value for the actual accident itself and identify new recommendations or more broad recommendations, but it also allows you to assess the quality of the report itself and potentially give you an indication as to the quality of the investigation that generated that report. Because obviously if you do a CAST accident analysis and identify loads of things that are not covered in the report, obviously that then calls into question whether the investigation itself was done to sufficient standard. And I see this a lot with existing near-miss investigations. So because it's not an accident investigation, they don't necessarily go into great detail, and that means they don't necessarily take advantage of the opportunity to go to town and identify everything that needs to be managed. So it's almost a lost opportunity. So before I go on to the next question, I'm just going to try and start Facebook Live up again and see if I can get that working. So let's just start streaming. Let's see what happens. So it seems to be doing something. It says it's live. It says it's live, but it doesn't seem to be. No, it doesn't seem to be working. I don't understand. Videos. Live. Doesn't seem to be. It doesn't like it at all. Let me just try this again. Tools. Settings. Right, let's try that again. Start streaming. Right, it says it's streaming. So it says it's, oh, it apparently is streaming. Excellent. Right, well, I'll just close that so it doesn't blow up anymore. Okay, so just have a quick drink. Right, is it working? Yeah. Right, so yes. So Cathal says, where it diverges from existing investigation and how it is done practically. Okay, so the CAST accident analysis method doesn't strictly diverge from an existing investigation approach. All it does is supplement it and enhance it, put it on steroids, supercharge it if you like. You know, so as part of your normal investigation process, if you include at its core the CAST accident analysis process, so building the control structure, iterating the control structure, analysing the elements and structure of the control structure, that activity can enhance and supercharge the investigation as a whole, and maybe even it'll definitely make it more effective and identify more specific recommendations. I mean, really specific, not just the general oh, this group of people needs to do a review of operational procedures. No, cast accident analysis will tell you specifically where in those operational procedures and what needs to be done. And that's one of the superpowers of this method. Okay, so Peter says, how can I accelerate its use across an entire airline? That's a brilliant question. I need some clones. I need some volunteers. I need people that I can train, mentor them, support them, coach them in learning the method and its application. And this is why I'm using the wonders of the internet and social media to be able to communicate, because then I can communicate and influence more people more quickly, and that's why I'm doing it. So I suppose one way would be to put everybody on my course. Obviously it's my first course, so we'll see how great it is. Maybe version 2. But getting people on the course, or getting people on the webinars or watching the videos, going to MIT, going to the events in Amsterdam, Iceland, Germany, wherever they are, getting involved with the community. Because this is the other thing. What I found is the groups of people I've met are not just safety engineers. There are people from all over the place: pilots, engineers, managers, regulators, investigators. Everybody who is passionate about safety and doing the right thing, and they come together with this, come together at MIT, for example, and the community is great. Everybody's really friendly, really helpful, and they're all going through the same struggles with safety techniques, all of that stuff. And it's just great to all get together, talk about these issues, and see something being used, and use something that is so effective, so much better than the other methods. And the only real challenge is really getting it into the mainstream and helping people learn it, practice it, and get great results. And that's what I'm trying to do. Flynn has said about decision-making matrix and red team analysis. So can it help with that? Now, I'm not entirely sure exactly what that is, but I get the impression it is an operational set of terminology that refers to making decisions, immediate decisions, on whether to investigate incidents, near misses, and to how much level of detail. Once you become really used to building control structures and understanding the systemic aspects, if you're on those kind of red teams and you have an incident that comes in, you will be able to build a control structure very quickly and make a decision as to whether it's very serious, and you might even need to stop operations or suspend operations. And an example of that is the recent air traffic control example I mentioned earlier. So the controller-pilot data link communications issue that was identified, so where the message was delayed for 24 hours, I think it was. If I was a part of the flight operations management, safety management for an airline or the military, and that incident had been reported, that to me is a very serious safety issue, and I'd immediately stop operations with the CPDLC until there was a conference called to talk about those issues across the control structure. Because it could be an individual aircraft avionics issue. It could be our pilots and operators not operating the kit properly. But I would have expected that something as serious as a flight level change message being received after 24 hours should have been eliminated in design. And obviously, having worked in design of some of not this particular kit, but electronic communication systems and computer systems, that kind of message and its delivery at a time that's dangerous should have been identified in the original safety analysis. There should have been a safety requirement that explicitly says the computer shall not do this. And if the computer is not designed that way, there should be some other mitigation in place that has obviously been inadequate in that particular scenario. So yes, using this method as part of immediate risk decision making, that's where you'll get massive value. But obviously it takes practice and tuning and having people with appropriate experience across different parts of the control structure. I hope that's answered that question. And then finally, so the final question. So George, how to apply it to near misses, how to simplify it to apply to a short investigation, to low consequence events, like the vast majority of reported occurrences of a safety reporting scheme? So this is a brilliant question. So the first thing we need to be clear of is when we have a near miss or a low consequence situation, occurrence, event, whatever you want to call it, just because it's low consequence doesn't mean it was very serious, and analysing it will give you some serious benefit. Because obviously if you've not had an accident and killed loads of people and destroyed some assets, you know, the emphasis on investigation is less because it wasn't very serious. And that is an example of what's called outcome bias. So the outcome was not very serious, so we don't need to worry about it. No, that's not the approach at all. Just because the outcome was not very serious doesn't mean there's not a serious systemic problem in your organisation or your system. And that's where CAST, if CAST is used in that scenario, you'll get so much more value because you're saving yourself potentially from a real accident further down the line. And so this is where I talk about the learning. I intend and I want you to leave the training confident enough to be able to start applying it as early as possible in these incidents, so that you can start to think, well, this is the near miss that we've had. What are the systemic aspects of that? What are the interactions that have occurred? You know, just because on this occasion it was a minor outcome, we've now got an opportunity to go and talk to people. You know, for example, if somebody has, you know, if a human has, you know, an operator has taken an action which could have resulted in an accident but fortunately didn't, like runway incursion, or like the Air Canada situation that I'd done a video on earlier on, we need to take that opportunity and go learn about it, because all of those near misses demonstrate that the control structure was not adequate to enforce the safety constraints. And so we know that the safety constraints have been violated, so we should go and take a good look. And I suppose over time, as you get more experience with this and the team gets more experience with this, you'll be able to start to tell which incidents are, oh, that was close, we need to do something. Or, oh, well, this was a relatively minor issue, it was low complexity, it doesn't indicate systemic issues, it indicates local issues, then that's fine. But that comes with time, that's a skill that you develop. But it's really important, and if I can emphasize one point, this method can be applied to accidents or incidents. Any of those, any occurrence you want to use it, and you can do it to a particular level of detail you want to do it to, it is customizable. But the earlier that you use it, if you use it as an incident investigation method, you'll get more value out of it because you won't have a smoking hole in the ground with 500 dead or whatever it is. You know, the company won't be going out of business because it needs to pay a bill of 10 billion or whatever it is. So it's in everybody's interests, and this is where I really want to emphasize, it's in everybody's interests to apply this method earlier before an accident occurs. You know, that's it, basically. Okay, so that's the end of the questions and answers that everybody has asked. And so I'm going to throw it open now for everybody to sort of ask questions. And if there's a couple of people watching, so if you do have any questions, please type them in the comments box. Let me just get the Facebook picture open so I can see if there's any comments, questions. Hello YouTube, please ask any questions. Right, Facebook, let's see what Facebook does, see if they're still awake. It's really good though. I quite like this. I don't think I'm going to try and stream at the same time next time. I think I need to come up with some other way of doing that. Right, so YouTube, I think everyone's gone quiet. Still quiet. Come on everybody, wake up. Right, what's happening on YouTube? Come on YouTube. Why isn't it working? It's just collapsed. It's collapsed. I don't think YouTube's playing at all. No. No, I think YouTube is a failure. I think, actually, I've got an idea. Hang on a minute. No, hang on. Right, Facebook. So it doesn't seem to be, well, it seems to be on there. Okay. I don't understand that at all. Well, I think I'm going to abandon Facebook then. I think that's not going to work. So I'll keep going with YouTube. If you do have any questions, please type in the box and I will address them. Hi Demetrius, which links you want? There we go. Right. Well, I think we'll call that a success. Maybe. I don't know if I can take the YouTube stream and upload it to Facebook. I think I'll give that a try. Right. Well, thank you very much for watching the live stream. I hope I've answered as many questions as I possibly can. If you do have any other questions, please stick a comment in there or go on the website, drop me an email, and I'll get right back to you. I'll see you on the next live stream video training course. Have a good Saturday. See you later.